All right, this is a video on solids of revolution using the disk method, which kind of goes along with another video that I've posted using a web applet. So that's how I'm going to have you start with that one, because that's how you're going to understand this problem a little bit better. So start with that, and then start this video over again. So we have f of x is equal to 2 root x. And we're using an interval from 0 to 9. So what we're doing is we're integrating from 0 to 9. The volume of a disk is pi r squared h. The pi is in there. The radius comes from our function. It's being squared. And then the height of each of those disks is dx, so we're making those infinitely small by using the integration and the fundamental theorem of calculus. Okay, so again, if we were to look at this scenario, here's 0, here's 9, 1, 2, 3, square root, call it 6. So what we're doing is we're rotating this around the x-axis, and kind of looks like this. You end up getting a kind of a bullet-shaped object, and we're basically taking a cross-section of that, making it infinitely thin, finding the radius, which in this case, since we're rotating around the x-axis, is the height of the function, also just f of x. We rotate it around. We find the area of each of these circles, add them all up, and we get our answer. So we square 2 root x, we get 4x, keep the pi in there, factor out the 4 pi, integrate, evaluate, multiply, and we get 162 pi. Let's do a few more examples. We're going to shift our axis of revolution a little bit. So we have a new function, x squared plus 2. It's graphed here. Okay, so 0, 2, 1, 3, 2, 4. I am stopping at 2, 4 because my interval is from 0 to 2. These are in terms of x, which is important. And we're going to rotate around y equals 1. So this is my axis of rotation. And you can see in the graph here, what I've done is just kind of imagined this radius right here, rotated around, would form that circle. This radius would form that circle. That's too far. That circle. And this radius here, which is 5, would go all the way down to -4. And it would form that circle. So we get this shape. Now, if we cut those apart and we looked at one radius, no longer is the radius the distance from the point down to the x-axis. It is 1 less than that. Okay, everywhere I go. So here's the height is 2, but the radius is 1. The height is 3, the radius is 2. The height is 6, the radius is 5. Okay, and I've got those right here. What we've done is at 0, g of 0 is 2, subtract 1. At 1, g of 1 is 3, subtract 1, get the radius. And in each case, what I'm doing is I'm taking the y value of the function, which is really x squared plus 2, and then I'm subtracting the y value of the axis. So g of x minus 1 in this case. X squared plus 2 minus 1 gives me x squared plus 1. So everywhere I go, the radius will be x squared plus 1. That goes into my definite integral. X squared plus 1. Okay. I'm not going to go through the whole evaluation process, but here, what I would do is I'd factor out the pi. We don't really need pi gumming up all of our algebra, and I would square that binomial. before I did my integration and evaluating. So that's a prior lesson. I'm not going to spend a ton of time doing that. We would evaluate that and we would get an volume, excuse me. Let's talk about what happens when we have to rotate around the y-axis. So we have a function. I've kind of backed off the complexity a little bit. We have f of x equals x squared, but we are given our bounds in terms of y. So our y values, we want to go from here to, 0 to 4, and we want to rotate around the y-axis. So again, it's another bullet-shaped object, just because I'm using parabolas. But notice that the radius is not based on the height of that function. It's based on how far that function is from the y-axis. So what we have to do is, or one of the options, is we have to take our function. Again, f of x and y are synonymous, so I'm going to say y equals x squared, and I'm going to solve for x. By solving for x, I get x is equal to the square root of y. So this distance, which we know is the x value of that function at that point, is the radius. And in terms of y, it's the square root of y. And think about it. If we were at 2, we'd be at 4. So working backwards, if I wanted to get that 2, I take the square root, no matter where I am on this graph. If I was at 9, I'd be at 3, the square root. So we need the radius in terms of y because the y values are also in terms of y. Now, again, pulling the pi out of the formula, I have radius squared, and the dy represents the height. Then we're going to evaluate. This one's pretty easy. We might as well just do this one out, because when I square that square root, I just get y. When I integrate y, I get 1/2 y squared. Plug in the 4, 16 times 1/2 is 8. Plug in the 0, and then multiply by pi. 8 pi is the volume of that shape. And of course, we have to also look at what happens when we shift over, when we rotate over a shifted vertical line. So basically, instead of the y-axis, we're going to use a different vertical line to rotate. Now this graph, I apologize, is really hard to visualize, but what we have is the function root x minus 4, that's here, and we have from y equals 0 to y equals 3, so we're starting at 0, we're stopping at 3. That's why you can only see that portion of the graph. And we're rotating it over this dotted line here at x is negative 2. So the real key here is to find the radius. And a lot like the other problem where we had to subtract the y value from the y value of the function, we have to do the same thing after we solve for the x. So first off, here's my function. I'm going to solve for x, which means I square both sides, and then, oh, I messed up here. Then we have to add 4. And all of that work is going to be for naught, so I'm glad I caught that. Yeah, we're going to adjust this. Whew. All of that's going away. That's too bad. No worries. So we take our y squared plus 4 equals x. That is equal to this. Okay, y squared plus 4. So if we're at, let's say 2, square it, add 4, we get to the value. Okay, so that would be right here. Y is equal to 2, square it 4, 1, 2, 3, 4, add 1, 2, 3, 4, we're at 8, just to double check. Then we subtract the value of that vertical line, which is -2, minus the -2 is add 2, so we get y squared plus 6. Now, in order to save time on this video, again, I'm not going to go through the whole process, but I'm going to square the binomial. That's y to the 4th plus 12y squared plus 36. Still from 0 to 3, still pi on the outside as a constant, and still in terms of dy, we integrate using power rule. I'm not going to do the whole thing. I'm going to stop after this step. We get 1/5 y to the 5th plus 4y to the 3rd plus 36y. We're evaluating from 0 to 3. Plug them in, subtract, multiply by pi,